There is another data type used in C. It's called a string. A string is used to store words or text. For example, somebody's name or their address, or some random piece of text that you might find, not necessarily text from a book. I'm talking about just any kind of old character, punctuation marks, unprintable characters, anything from the ASCII character set. These need to be stored. They're stored in what we call a string. But a string isn't really a data type in its own right. It's actually a derivative data type of the char type. Remember char? A single character, like the letter P or the backslash or something like that. Well, a string is a lot of those. It's a collection of those. In fact, it's an array of those. That's the technical term we use. It's an array. You don't really know what an array is yet. You'll be discovering more about arrays in a later chapter. So we're going to have a bit of an introduction to arrays now. A string is an array of characters. But there's a special thing about strings that's separate from just an array of characters. A string is an array of characters that is terminated by a null character. And what's a null character? A null character is it's a very special character. It's the 0 character. It's not the digit 0, as in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's actually the very, very first character in the ASCII character set, number 0 in the list. And for that reason it's called the 0 character, but we are going to refer to it as the null character. Let's turn to our compiler now and examine some of the ways that we can declare, use and manipulate strings. Here is a very simple C program. In fact, it's very similar to our Hello World program. The only difference is that I have changed the printf here from the words Hello World to this is a basic program. Notice we've still got our fflush, our getchar and our hash includes to io.h. I'm going to use this as a basic template for all future simple C programs because it's got all the bits that we need already done. So anytime I ask you to create a new program from scratch, you might just want to open up a file called basic.c. I've actually stored that as basic.c on the CD for you. Anyway, I've saved this one as string.c and we're going to use this as an example of how to use strings. Actually, if you look closely, you'll notice that there is already a string in this program. Can you see it? Well, it's the red bit. This is a basic program. That is a string already. In fact, anything that you see inside double quotes in a C program is a string. In this case, it's a string literal, in the sense that the literal text that's going to go in the string is encoded into the source code. The string looks like this. It's the 5 words, this is a basic program, followed by a \n. I need to explain some not quite obvious features of this particular string. The first is that the \n is actually treated as one character by a C compiler. It's actually typed in as 2 characters on your keyboard, a \ key followed by an N key, and it looks like it's 2 characters on the screen. But the compiler reads it as 1 character. Whenever the compiler is reading a string literal and encounters a /, it thinks, all right, this is going to be a special character, and what's the special character going to be? And it's going to be an N in this case, which means a new line. So it just treats that as a single character, the new line character. So that's the first non-obvious thing. The second non-obvious thing was the reference that I made to just a moment ago about the null character. I told you what a null character is, but I didn't tell you why it was important. The null character is also known as the terminating character, or the null terminator. And it is put on the end of an array of characters to designate where the end of that array is. In other words, it designates the length of the string. So, this is a basic program, carriage return, actually has a null character on the end of it. You can't see it. It's completely invisible, but I promise you it's there. So, let's count the number of characters in this string. There are 23 visible characters, up to and including the M in program. Then there is a single carriage return character, so that's 24. Then there is a null character on the end, which is invisible, we can't see it. The compiler puts it in for us. So that's 25. So the total amount of memory that this particular string is taking up in our program is 25 bytes. That's just an interesting fact for you to know. Before we leave the topic of the null character, it is very important that whenever you are declaring a string that you leave space for the null character. If you decide that you need 100 bytes worth of space to store your string, then you must declare your string to be 101 bytes long. Let's look at how that's done. I'm going to show you how to declare a string. What do we call our string? Well, firstly, it has to be a char character type. It's not a single char, it's going to be an array of chars, and I'll show you that in a moment. What shall we use this array for? Let's say somebody's name. So we'll make the name of the variable the word name. Now, if I was to put my semicolon there, I've just declared a single character, like a P, or an underscore, or a new line character, or even a null. But I don't want a single character, I want an array of characters. So I use an open and close bracket, like that. That designates an array, but I'm not quite finished yet. I haven't yet said how big the array is. What I haven't said is how many characters I want. So how many characters do I want? How many would it be reasonable to have in a name? Well, what kind of name? Name of what? Or how about a person's first name? How many characters are in a person's first name? Do we need to know? Well, yes, we do need to know. We have to set a limit on the number of characters that this program can reliably read in as a first name. We have to do that. Whether we set it to 10 or 100 or 1,000 or 1,000,000, we have to do it. So in the interests of efficiency, efficient use of memory, we try and think of the smallest number that's going to cover all the possible options. So how big is the longest possible name? Well, let's not worry about that too much, but let's say that 20 characters is as long as a name can be. So I will create a 20 character array, but I've forgotten something, haven't I? If you think back to what I told you a moment ago, I actually need, let's say, 20 characters for the name, but I need 1 character for the null. So I've got 2 choices here. I can either change this to 21, meaning that I've got 20 characters for the name plus 1 for the null, or I can leave it back on 20, which means I've still got 1 for the null, but I've only got 19 now for the actual name. Well, which do we choose? It depends on the specification. If somebody has said to you, I want a program there where the name is going to be 20 characters long, if that is the specification for your program, then you need to make it 21, because you must allow for that null. Okay, so this is now a complete declaration of a string. This is what it looks like. It's a char. The type of the variable is a char. Then you put the variable name, and then you put an open square bracket, the length of the array, including the amount of space for the null, then a closed bracket, and that is it. That is the declaration. Okay, let's see how to use it. I'm going to say, alright, name equals Mark. Is that right? Well, it might look right. It would be the obvious thing to type, but it's actually not right. And it's got nothing to do with the fact that Mark is not 20 characters long. Let's examine this a little bit more closely. Firstly, we need to understand that we need the quotes. Just like we need the quotes down here in printf, when we declared this string right here. Anytime you declare a string literal, you must put double quotes around it. If you don't, if you, for instance, put that instead, what that does is it tries to assign name the value that is in a variable called Mark. In other words, it looks for a variable called Mark in the program, and there isn't a variable called Mark. If there was one, it would try and extract the contents of that variable and put them into name. In other words, take the contents out of the Mark box and duplicate them in the name box. But we don't want that. There is no variable called Mark. It's actually a string literal, so we put quotes around it, and that's what we get. However, it's still not right. The reason it's not right is that because name is an array. Name is an array, and you cannot assign arrays using the equal sign. You can only assign individual entities, individual variables, like a single integer or a single char or a single something. That's the only thing you can use an equal sign with. You cannot use an equal sign with arrays. So we must use some other technique. What is that technique? Well, I'll show you. This is what it is. strcpy, open brackets. Then put a comma after that, get rid of the equal sign, put a closed bracket. Now the name is complete and correct. Strcpy. That's how you pronounce that, S-T-R-C-P-Y, strcpy. Or you can say string copy if you like, if you want to be literal about it. String copy is a function from the standard C function library. It copies the contents of one string into another string. In this case, it copies the string literal mark into the variable called name. It always goes from a right to left direction. That is the from and that is the to. That is the from, that is the to. Just like if there was an equal sign in there, saying name equals mark. It is assigned in a left direction. The data travels in a left direction. Anyway, that is the correct way to type it. Name, comma, mark. And that will assign the string mark into the variable called name. So we need to find out if that worked properly. I guess we can do that using a printf. If we design our printf properly, we'll be able to find out what's inside name. Let's do it like this. The contents of name are... Now remember how we did this before when we were using integers. We put a %d and then we put a comma age like that. Remember that? Okay. Now we're going to do almost exactly the same thing, except obviously there's no variable here called age. So we're going to use name instead. Now name is not an integer. Name is a string. And this %d here is only used with integers. Remember, d stands for decimal number, which is kind of wrong because it's actually an integer, but never mind. D is for number. In this case, D is for integer. And name is certainly not one of those. So we remove the D and we put in an S instead, S for string. So theoretically, our printf statement will now show us the contents of the name variable. So we should get output on our console. The contents of name are mark. I'm not sure if that's grammatically correct, but you get the general idea. So let's see if that compiles and runs as we expect. Okay, so we go up to the compile button. Compiles successfully. Total error is 0. Thank you. Now we go to the run button. The contents of name are mark, as we expected. The program is working. So I've shown you how to declare a string like this, and I've shown you how to assign a value to a string like this. I've shown you how to print out the contents of a string like this. What else can you do with strings? Well, I've prepared another program to demonstrate some of the other ways that strings can be manipulated. That is in a file called string2.c, which I will now open up on the screen. Here is string2.c. As you can see, there's a little bit more to it. Let's have a look at what's going on. I've created this file to demonstrate some other uses of strings. In particular, some of the standard C library functions. I've shown you one already to do with strings, and that's strcpy. It takes a string and assigns it to another string. But I've got two more functions for you to look at. Strcat and strlen. Strcat stands for string concatenate. And concatenate means to add something to the end of something else. So you can probably imagine what's going on here. Something is being added to the end of something else. In this case, name is being added to the end of string 2. So it's extending an existing string by adding some stuff to it. And again, strcat is used again to concatenate a one-character string that might look like two characters, but it's really one, and the one character is a new line. Well, if you want to be really pedantic, there are two characters. The second character is a null and it's invisible. It's assigning a one-character or two-character string to the end of string 2. Okay, so it's adding it, it's concatenating it to the end. Down here we've got strlen. It's another function. Strlen is a function that counts up the number of characters in a string and returns them to you. It tells you, in essence, how long the string is, how many characters are in it. But that does not include the null character. It does include the new line character, if there is one. But it does not include the null character. In fact, it includes every single character in the ASCII character set except for the null. Now, this line is a little unusual. You haven't seen this kind of construct before. All the previous functions that you've ever seen in this course, strcpy, printf, scanf, fflush, getchar, they're all functions, and they're all called, as we've just seen, and they're not called like this. Here we're calling a function, and then we're putting that on the right-hand side of an equal sign, and then we're putting an integer on the other side of the equal sign. What's going on? Well, you can probably guess what's going on. String is a function, but this time it's a function that returns us a value. It gives us a value back. Once it has done whatever it is that it was going to do, it gives us a piece of information. These functions do not. This function simply adds name to the end of string 2, but it doesn't give us back any information. This one does. It gives us back an integer, and the integer is the length of that string, which we then assign using the equal sign to the length variable, which you see the length variable up here. Before, you might have noticed that integers were assigned. You might have seen something like length equals 4, or length equals 4,000, or something like that. Now we're having length equals, and then the results of an actual function. Now, moving right along, we have a look at the printf statement. Printf, the length of the string, and then what's this here? Well, we've got two less than signs, those are greater than signs, and then two less than signs and a %s in between them. Well, the less than signs and the greater than signs are just for decoration. They don't really do anything. They're not special characters in any way. They're just to show you where the string starts and stops. So what happens is here we should get an entire representation of that string, string 2. Should be placed inside those left and right brackets, if you want to call them that. So what will be the contents of string 2 if we run this program? Well, let's have a look. String 2 is initialized here in the string copy, and it starts off with my name is, and then a space. And then we put name on the end of that. Now name was given the value Mark, so we'll get my name is Mark, and then we'll have a carriage return put on the end of that. So we'll have my name is Mark carriage return. So all of that will be put in between those brackets. And then we'll have is, and then a certain number of characters, %d. That's an integer. Remember, %d outputs an integer, and the integer will be this integer here, the length, which we get from here. So we'll get a full representation of the string, followed by the number of characters it is. So we'll find out the string and its length in the same process. Let's see if that works. So to compile the file, we go up to the compile button, 0 errors, and run the program. My name is Mark. The length of the string my name is Mark is 16 characters. Okay, notice that after the word Mark there is in fact a carriage return, because a carriage return is part of that string. So the closing brackets, as I'm referring to these things, happen to be shown on the next line. That is expected behavior, simply because of the contents of my string. Okay, good. Back to the program itself. I'll just get rid of this error box down here. That's better. Now, there was one line in here that was quite interesting. Printf string 2. We haven't seen printf used quite that way before. The only way we've seen printf before is when you've got a literal string. Quotes, the length of the string, blah, blah, blah. But if you recall, this whole red bit here is just a string. In fact, printf requires its first parameter to be a string. So, any string will do. This string will do right here, string 2. We've already built a string with a new line on it. Why not use it? So we do. Printf string 2. That works perfectly well, as you've seen from the output just a moment ago. So, we've seen that strings are an array of characters, and that they have null terminating characters on the end. We've also seen that we can't use equals to assign a value to a string. We must use strcpy instead. In fact, the only way that we can manipulate strings is by using standard C library routines. strcpy, strlen, strcat, and printf are the ones that we've seen, but there are actually several more, all of which can be found in the header file, the .h file called string.h. So if you have a C standard library reference in front of you, look up string.h and you'll find a great list of string functions. Do not ever forget the null character. Sometimes you won't need to worry about it because it will be automatically handled. strcpy, strlen, strcat, they all use it. Printf will have no trouble with it, and string literals have them built in by default. But sometimes you have to build a string from scratch, character by character. You have to individually insert each character into the string. M, A, R, K. You have to build a string letter by letter. And you might think that after you get to the K, your work is done. You don't have to do anything else. Well, you do. You have to set the fifth character as well. That has to be set to a null character. What I'm going to show you next is how to do that, how to set the value of each character of a string if you need to. So here we are back at our first string program. I actually renamed it now to string3.c, as you can see, and we will now be changing this program to show you how to use individual assignments of characters within a string. Strcpy does it all in one hit for us. mark is assigned to name in one statement. I'm going to now show you how to do it if you need to do it explicitly, character by character. I can't imagine that you need to do it exactly like I'm going to show you very often, because that's not something people do. They just use strcpy if that's what they need. However, we do definitely need to see how to assign values to individual elements of arrays, not just strings. It's a very important part of C. So we may as well use a trivial and simple example like this strcpy example as that. So off we go. Firstly, we need to get rid of this strcpy. So it's gone. Next, we start by assigning the very first character, which will be the letter M. And we do it like this. Name, bracket 0, equals M, semicolon. Now the semicolon is pretty standard and the equals is pretty standard, but the rest of it may be a little bit confusing. Whenever we need to reference an individual element of an array, any kind of array, not just a string, we use the square brackets, just like we use the square brackets to declare an array. So what's that 0 doing in there? The 0 is referring to the very first element of the array. Now that might look odd to you, especially if you've come from a programming language like BASIC or Fortran, or even Pascal, I believe, where array indexes start at 1. You might think that the very first element of the array name is supposed to be name 1, not name 0. They might go name 1, name 2, name 3, name 4, and so on, all the way up to name 21 in this case. Well, I'm here to tell you that in the language of C, it does not work like that. That's one of the very first rules that you have to learn about C, where it differs from other languages, is that arrays always start at 0. And they don't go up to, in this case, 21, they go up to 20. Let me summarize. The individual elements of an array, if the array is of length, say, n, they do not go from 1 to n, they go from 0 to n minus 1, like from 0 to 99 if the array is 100 characters long. So, name is an array of characters, while the first element of name is a single character, and single characters are always denoted using single quotes. Strings are denoted using double quotes. Thus, our line is complete. Let's build the second line. Name 1 equals A. Name 2 equals R. You can see where this is going. Name 3 equals K, semicolon. So, we're done, right? How many people just nodded their heads? No, we're not done. Now, as an exercise for you at home, if you want to do this, copy exactly what I've written into a source file and compile it. See what the contents of name are when you run the program. Name will be printed out here using this %s. See if you get what you think you're going to get. This is an illustration of why you need the null terminating character, which is what we're going to put in now. Finally, name bracket 4 equals, and here's how you designate the null terminating character, quote, \0, quote, semicolon. That is actually one character. It might look like two, but it's actually one. Just like \n is a single character. Anything that's got a backslash in front of it is a single character. Our string is now complete. There is another way to represent the null character. It's like this, just the number 0. But I like people not to do that because it makes it look like it's an integer. I mean, it is an integer. and it will work, but it's slightly more readable if you do it like this, because it's really clear then that what we're assigning is one character, not one integer, even though technically they're exactly the same thing, for reasons that I'm not going to go into right now. Now you might be thinking to yourself, well, what about all the other characters in the array? What about from the 5th character, or the, if you like, the 6th character, all the way up to the 21st character? What do they get set to? Well, they don't get set to anything. So what do they have in them? Well, they've got just random pieces of memory in them. They could have any characters in them. They could have garbage, complete nonsense, which is fine. We don't care about those characters. They're not part of the equation. When printf prints out that string down here with the %s, it will print out the m, the a, the r, and the k, and then printf will notice that there's a null terminating character in the next spot, and it will go, aha, that's the end of the string, there's nothing more to worry about. And all the other 15 or 16 or however many characters there are after the k and after the null terminating character will just get ignored. So that concludes our lesson on how to assign individual characters to individual parts of your string. They obviously do not have to be done in that order. You could start with the 4th one and go all the way down to 0 if you wanted to. Of course, we better check that that works. So we'll just compile it now. Compile's OK, and we'll run it. The contents of name are mark, as before. Excellent. Strings, as I mentioned before, are part of the greater C family of operators known as arrays, and we're going to be learning about arrays in the next chapter or two.